Hello everyone. In this video, I will be discussing the second learning objective of week 8, interpret a chi-square test for a contingency table. So as I mentioned in the last video that we will be discussing three tests today. One is the chi-square test, then t-test, and then ANOVA. So here we will be discussing chi-square test. First of all, when do we use a chi-square test? When we have two variables and both the variables are nominal, this is important, both the variables are nominal and we want to compare between these two variables, then we use chi-square test. Particularly when we are comparing observed frequencies with expected frequencies of interval scales, nominal or ordinal scale variables, we use chi-square test. Chi-square test, in other words, we can say, is a test of the statistical significance of a contingency table. Probably you can remember we discussed about contingency table not last week, the week before, that in contingency table we show a frequency distribution of two variables, one variable in the vertical axis and one variable in the horizontal axis. I mean one variable in the row and another variable in the column. So if there is any relation between two variables placed in a row and column, and when the variables are nominal or ordinal scale, then we use chi-square test. I think you can remember Papa John's Pizza Restaurant example in the last class, last lecture. We have used the same example for a univariate chi-square test. So they made a survey about the location of their stores. So among 100 stores, they found that 60 stores are located in a standalone location and 40 stores are located in shopping malls. So in the last week when we discussed univariate chi-square test, we had an observed frequency, an expected frequency that the stores in standalone locations and shopping centers are equally distributed. That means 50 stores in a standalone location and 50 stores in shopping centers. So that was expected observation, and these are the actual observation. So we compare this expected observation with the actual observation or expected frequency with the actual frequency by chi-square test, and we rejected our null hypothesis that expected and actual frequencies are same. So that was univariate test. Now we extend this univariate test to bivariate. How we do that? Look, 60 stores located in a standalone location and 40 stores located in shopping malls. These are the totals. Now we introduce another variable that is profitable and not profitable. So previously it was only location, standalone location and shopping centers, 60 and 40. Now we introduce another variable, profitable and not profitable. So among the 60 stores, those are in standalone locations, 50 are profitable and 10 are not profitable. And 40 stores, those are located in shopping malls, 15 out of 40 are profitable and 25 out of 40 are not profitable. 25 out of 40 are not profitable. So among the 165 are profitable and 35 are not profitable. So you understand that initially we had only one variable, that is location, and now two variables. One is location, another is profitability. But what is the measurement scale of the variable? In location, we had just two alternatives, the standalone location and shopping center. So that's a nominal variable. And profitability, we again have just two alternatives. One is profitable and not profitable. So it's also a nominal variable. So don't confuse with the term profit. If we have profits in terms of absolute dollar, then it would have been a ratio variable. But here, we do not have profit for these stores in absolute dollars. Rather, we are simply categorizing them either profitable or not profitable. So it's also a nominal variable. So two variables, location and profitability, both are nominal variable. And we just want to compare these two variables, that whether there is any impact of location on profitability or not, but by chi-square tests. So these are our actual frequencies, and now we calculate expected frequency. How we do that? 60. So we multiply the row total with the column total, 60 into 65, and we divide it by the total 100. We get 39. Here the row total and column total divide by 100. And similarly, row total, column total divide by 100, and in the similar manner. So we get these numbers 39, 21, 26, and 14. So these are our expected frequencies. So we want to see that if these expected frequencies and actual frequencies are same or not. So if we use the equation that we have seen in the last class to calculate chi-square statistic, we will get a chi-square statistic. We will compare it with the table value, and we will say that if the null hypothesis is rejected or accepted. Okay, so this is how the chi-square test is actually conducted. The good thing is when we use a statistical software or Excel spreadsheet, we will directly get a p-value, and looking at the p-value, I mean comparing the p-value with the significance level, we will be able to say that if we reject the null hypothesis. Okay. So this is chi-square test. Just to remind you again that it tests the significance of statistical significance of contingency table, and it tests that whether expected frequency and actual frequencies are different. So this is the end of our discussion on learning objective 2, that means chi-square test. And next video will be on t-test. Thank you.